Welcome to our Focus25 webinar episode on smarter robotic glazing with 3D-ProSim. In the following, we explore the challenges of shop floor programming and show how offline programming can reduce downtime, material waste, and costs while improving quality and production throughput.
Good morning, everyone. I hope you're all doing well, and thanks for taking the time to join us to today's webinar, Focus25 Stop Programming Robots on the Shop Floor. 3D-ProSim, a smarter way to glaze. My name is Michael Redke. I'm a technical sales engineer at Adalogic, and together with my colleague Samuel Ovotoki, who will take you through the main part of today's presentation. Who is Adalogic? Adalogic is a German software company. We are a subsidiary of the GFAI, one of the leading non-university research institutes for applied computer science in Germany, and that we do, or they do, for more than 35 years right now. Our expertise is in automation, robotics, image processing, digitalization. We are turning research into practical industrial solutions. So let's start with a webinar about 3D-ProSim. Samuel will now show you how it works in practice. Samuel, the stage is yours.
Great. Thank you so much, Michael, for the warm and great introduction. Well appreciated. Yes, good morning, good afternoon, good evening from everywhere you're joining us in the world. We are very glad that you could join us today for our flagship webinar, Focus25, Stop Programming Robots on the Shop Floor, 3D-ProSim, a smarter way to glaze. And my name is Samuel Ovotoki, and I'm the responsible technical sales manager here at Adalogic. And without further ado, I would love us to dive right into it for what we've prepared for you today. So starting, we want to speak firstly by why glazing efficiency matter, right? So glazing efficiency matters because it impacts appearance and surface smoothness of the final piece, right? So by distorting a final piece with a smooth surface makes the overall body looks good and pleasing to the eyes. I would like to use the analogy here of a cake here. So when we have a cake, we have the inside crumbs, then we have the icing on top of it. So imagine a cake without the icing, it wouldn't look good, but with the icing itself, it makes it look attractive to the eyes and smooth on the surface. Then secondly, efficient glazing also defines final product quality, right? And what does this mean? It means how stable the durability and the longevity of that particular piece, right? So just imagine when a piece is not efficiently glazed, it is susceptible to crack from the outer body. And when there's a crack on the outer body, it has the potential of getting into the green body. And once that happens, once water goes inside, it is susceptible to germs and various bacterial infection. And thirdly, glazing efficiency also reduces material waste. In this case, such as defects and excessive glaze consumption, right? So defects, how do we mean defects? So defects actually happen basically when the sanitary ware pieces are not evenly smooth and the thickness layer is not smooth enough, right? And by so doing, we got to have a higher number of rework. And a higher number of rework puts in much more work on the operator and the workers because they have to rework that particular piece before it goes out down to the customer. And also, excessive glaze consumption is always seen also because the spray part parameters are not evenly calibrated, and by so doing, excessive glaze and overspray are not well controlled enough, right? So using all of these factors, small inefficiencies like this increases production costs. Firstly, when a piece is not smooth enough, it's not attractive enough. Secondly, when the product quality is not durable and stable enough, it is also susceptible to easy break and easy damage. And also, when a defect and a rework has to happen and excessive glaze consumption, all these inefficiencies increases production costs drastically for sanitary ware manufacturers. Moving to our second point here, we have common problems of shop floor robot programming. As shop floor robot programming has been one of the conventional ways where sanitary ware producers actually program their robot, it has always been a big problem because programming this directly on the line causes downtime, right? And what does downtime mean in this particular case? Because when a program is being programmed on the shop floor, the production has to stop, right? And just imagine we have to program 2 hours every day, because sometimes we need weeks or even months to get a final good result for that. Just imagine we have to do that 2 hours every day. That piles up. In a sanitary ware factory that has about, let's say, 24 hours a day or 23 hours, right? These 2 or 3 hours is approximately about 10 to 15% of its general output, which is taking time from what the shop floor should be doing, which is producing sanitary ware piece that is supposed to go out to customers, right? Then secondly, it's huge dependency on one skilled operator, right? One skilled operator, and I mean the operator itself who operates this particular thing has all the knowledge in him. And when this person is sick or leaves the company, that particular plant is just one step from starting all over again. And also just imagine a robot that is down and a robot controller is sick or is no longer there. That is a disaster wouldn't happen for this particular plant, right? And secondly, thirdly, for trial and error patterning, right? Because glazing on the shop floor takes multiple time. We need to do various trial and error to get the right and final result. And also, I would love to mention one important point here. Doing this trial and patterning, where the program is being run with the glazes, it also exposes the operator also to inhaling glaze mist. And this particular glaze mist inhalation causes severe cases of silicosis in people, which is a very fatal lung infection, right? This is also a very big problem of shop floor programming, and also late collision and reachability discovery. Because the trial and error patterning has to happen on the shop floor, the collision and reachability discovery is done right on the way. And whereas with offline programming, this is done visually, and you can see the simulation and the trajectory, and you can quickly make that correction before it goes to the shop floor. Yeah, so what are the typical pain points basically in glazing, right? First off, we have complex product geometries, right? So we have bows, undercut, hidden surfaces, right? In sanitary ware production, due to the advancement, we have various product geometries. Some of the most complex product geometries are typically like the beaded urinals and also the smart toilet with various difficult undercut and trap ways to glaze, right? So because of this difficulty in getting there, it has always been a typical pain point in glazing. Then secondly, frequent product variants, right? Due to the different changes in the product variant and due to also customers requesting for various product variants also, it makes it also more difficult to keep up with this pace in the industry. And also excessive glaze waste. Excessive glaze waste, which is mostly caused by overspraying due to improper spray parameters. Because when you program on that particular way in the shop floor, the glazing parameters are not evenly calibrated in comparison to offline programming where everything is well controlled. So what offline programming does? What does offline programming does in a nutshell? So typically, it takes the production from the shop floor to an online environment, which is like a digital copy or digital shadow of your glazing environment, right? And it generates parts on a computer in forms of teach points, which is then simulated. And then after this simulation, you have the possibility of exporting this code. And once that is exported, you could also transfer this code to your robot controller. And from your robot controller, you can then go to the robot line just one time to see what you've done, which way you can then come back to calibrate till you get the final result, which you particularly need. Then 3D-ProSim, which is our tool here at Adalogic, the revolutionary offline programming tool that works with multi-robot types. We have a simple approach here to how how it works. So first of all, you have to import a 3D model of the piece. So this time it's taking the production from the shop floor now to the digital environment. Instead of you having the physical piece, you have a 3D model of it, and it's imported as a VRL or an STL file, right? Then when that is done, you can then define processes in terms of the spray parameters, which is more controlled this time around in comparison to shop floor programming, which is not, right? Then afterwards, 3D-ProSim itself calculates and simulates this teach point, and then it produces an optimal robot trajectory, which is then exported as a PTS file, right? And once that is exported, you can send it to your controller, and after that, you can validate this first before production, because we want to be safe also. You have to validate this on the floor. Then after that, once the test on the reproduction cell is up to satisfaction, then you can go on production live, use on the sanitary line, right? So maybe enough of this speaking. I'm just going to show you a little bit here what 3D-ProSim can do in real time. So I'm going to be moving my screen here now. Yes, so here we have a 3D-ProSim environment here, right? And here is a digital copy of the glazing area, the boot, the robot, and the piece. Yeah. So here, once in this particular place, it has taken away the production setting from the shop floor and taken it down up here into the digital copy. And the first process here we have to do is to go to File here, and then load a workpiece. We already have a workpiece here, but then we just have to load one here. Be that, you see it's an STL file, which is what is supported, right? Then when that is done, we can check everything well, and yeah, we see everything is good. Typically, we have to start from the home point here, which is where the glazing starts. Then once that is done and everything is set here, we can go here to create the process parameters, right? So the differentiation between creating those parameters on here and doing that online is because here you can actually check everything here, your process parameters. Here you can check the level of thickness of your glaze, how thick it is, whereas on the shop floor you can't. You just do a trial and error. So you create the process parameters here on how thick it should be, the density flow of the glaze coming out in gram per minute, right? We can also set that the distance of the gun from the piece and the angle also, right? And also here we have the possibility to set various programs for up to 8 different glazes. I know in the industry we have various glaze. We have the opaque glaze, we have the matte glaze, colored glaze, semi-matte glaze, or transparent glaze, right? So depending on which particular one we're using, we can set all of this here. And also, since most of us are calling from various regions of the world, we can also set our language also to match the particular language also from where we are calling from, right? So when all of this is done, right, then we can start glazing our sanitary ware piece, right? So it's just a quick one here. So we can just start by creating teach points here. So we create teach point here. We create another one here. Then we create another one, create teach points. Then, for example, also we can go to the difficult undercut here, which is typically the pain points, right, in shop floor programming. We can decide, we can make teach points in there. We can also make teach points. We can make even go further and make teach points, right, depending on our particular specifications, right? So once that is done, right, 3D-ProSim automatically calculates an optimal robot trajectory, right? And what that means is the final result is something like this. So now this is after the simulation has been done, it has created us a piece. Then this is the final result of 3D-ProSim after the points have been made. So yeah, that's 3D-ProSim in action, right? And here we can watch also the level of thickness of our glazing also, right? Very easy and intuitive approach, saving a lot of time. And also, this is taking away the glazing spray from the shop floor, right? Because in the shop floor area, most times there's a mist of glaze, which causes the silicosis, which I say. So it is also very important for health factors also that this is being done on the right on the digital area. Another thing again is this: when 3D-ProSim is being done like this, typically when a robot is programmed on the shop floor, when this particular line wants to expand or wants to go to another plant, they have to start all over again because it is not safe. But with 3D-ProSim, you can create a digital library of your program, then sending them to various plants or various industry. That way you have a standardized piece in all of your plants, right? So moving back to our presentation here, right? So after that's been said, so from this particular demonstration we've shown you guys, we've had customer experiences, real life customer experiences in their throughput and the impact 3D-ProSim has been able to be able to deliver for them. So for example, we have a particular customer, a global name, with a workpiece type, for example, a workpiece type of wash basin, right? They could achieve a glazing time of 60 seconds, right? And a workpiece change of 15 seconds. That is the loading and unloading of that piece. And calculating this on a 23-hour shift, that is 60 plus 15 given us 75, divided by that 23, they could be able to achieve 1,104 pieces per day. Right, this is one particular piece. Then secondly, we have the water closet. For the water closet, they've been able to achieve a glazing time of about 90 seconds, workpiece change of about 15 seconds, with a similar calculation resulting in 788 pieces per day. However, it is very, very key to know that the point of 3D-ProSim and why 3D-ProSim is smart is one of the very few reasons why 3D-ProSim is smart is because one, it removes programming from the shop floor, right? Relieving the shop floor of programming and making it do what it is supposed to do, which is producing pieces for the sanitary ware plant itself, so it could be exported to customers, right? Secondly, optimizing glaze quality also, and this is mostly achieved due to the spray parameters, which are evenly calibrated and set in the right angle. Because to achieve a very good glazing quality, you have to have the right glazing parameters set in place, which optimally increases the glazing quality. Then also reduction in downtime. That is taking the teaching from the shop floor and moving it to the digital environment using the digital copy of that. Then also reduction of waste and cost. Reduction of waste here could be the defects, the rework cost, the rework which has to be done, taking more time from them, and also the costs. Cost mostly, it's mostly accumulation of everything and mostly excessive glaze consumption, because due to high cost right now, glazing itself has been quite expensive. And also the supporting of the industry 4.0 in general. That's the automation of the global industrial processes. So while that being said, it is also very key to know that various factors also affect the dependency of the throughput, right? So 3D-ProSim on its own could do its particular work, but then certain factors also depending on the time it takes for that to happen. Example is the loading and unloading time of piece, right? Depending on the plant's time of loading and unloading, as various plants have various time in loading, some 15, some 20, some 30. So these are small factors that actually affect that. Then also product geometry, how complex the geometry is, the complex undercut, the trap ways where it's difficult to get to. These are also factors that affect that. Then also number of glaze layers required, right? As some customers have various layers they have to put on their pieces, right? Based on their policy. Some have a 1 layer or 2 layer or 3 layer. So with a 1 layer, you might need a lesser time compared to a 2 layer. With a 2 layer, you might need a lesser time compared to a 3 layers, right? So these are also factors to put in place. And also glaze characteristics and quality, as this also differs from plant to plant, company to company, and region to region. For example, a glaze characteristics in Europe has a different characteristics, and a glaze quality in a temperate and humid region like India also has a different quality. It's also very good for us to put this in place. Then production line configuration as well. How complex and less complex the production line is, how the dosing system connects with the robots and the turntables. So this complexity also adds up to that. In overall, from our customer experiences, they have seen a huge impact on the throughput, right? And some of these are increased production throughput, right? So we have had customers, for example, who've been able to produce more piece a day because of the various factors such as moving the production online, creating a right glazing parameter, which ultimately reduces rework and defects. It has increased production throughput using this factor, lesser rework and scrap as well, then also reduced glaze consumption due to less overspray and a more calibrated process parameters to effect that as well. Then in overall, it has made products, it has shortened the time to market for products and make it more faster for customers to get to market. And also not forgetting the lower load on the reclaim system. As it is with most plants, they would have a reclaim system in their glazing line to capture and suck out the excessive glaze, after which it is then disinfected and reused again. But because there's a reprocess parameter in line for that glaze consumption, they don't have to have an excessive load on the reclaim system anymore due to less glaze distribution. Many thanks to 3D-ProSim for that. Then also overall higher production profitability. We've seen customers after they're using a 3D-ProSim, they've had a month-on-month growth, year-on-year growth due to the excessive number of advantages they've been able to have with 3D-ProSim. Yeah, so with that being said, we've come to the end of my presentation. So I'm just going to run it back to my colleague, Michael, to check for us some of the questions we have so we can see how many of them we can answer today.
Yes, thank you very much, Samuel, for the interesting presentation. We have some questions from the audience, so I think also some interesting ones. First is, how does 3D-ProSim integrate with our existing robot system? Do we need to replace a robot?
That's a very great question, Michael. Very, very great and intuitive question. Thank you very much for that person. Straight to the point, no, actually, right? We don't have to basically, because 3D-ProSim is just an offline programming software, right? And it's basically designed to work with multi-industrial robots, right? Just name it. We have KUKA, Kawasaki, ABB, Fanuc, various types. But before we could work with this particular robot, we would have to get some certain information from you, the robot type, and also the documentation to check from our side also how we could effectively calibrate that with 3D-ProSim, right? So so basically the robot program, right? Because as 3D-ProSim is just an offline programming tool, right? So the robot program is just created and optimized offline, right? Then exported and transferred to the robot controller for execution. No hardware replacement is required for this, right? So practically what this means is existing robot remains in service for that particular plant, right? Then existing glazing equipment, right, and dosing systems continue to be used without being changed, right? Then existing robot controller just receives the code, which is exported as a PTS file, right? But then, like I said, also we have to get some information also to check your controller, the dynamics of your controller also to calibrate it properly for you. So basically, in principle, the result is an evolution, basically, of programming workflow, not a replacement of the production equipment. So in principle, no, you don't have to change your robot type. Thank you.
Okay, I think with time for one more question. How much improvement can we realistically expect in glaze consumption and productivity?
Good question, Michael. This is a very big question. Most of our customers come to us, and with 3D-ProSim, we've been effectively been able to give them a win-win situation since they've come to us, right? So the exact improvement depends on factors, basically, right? Various factors such as the product geometry, right? Glaze characteristics, like I said earlier, right? Production configuration and the number of coating layers required. Like I said, some of them need 1, 2, or 3 layers, right? So these are factors that are dependent on the glaze consumption. But with 3D-ProSim, you can easily control this because you have a defined spray parameters which is put in place. You have a defined flow rate, right? You have the angle of the piece from of the gun from the workpiece. You know where to spray slower to avoid excessive distribution, right? So these are factors that actually make this happen. And also, it is also key to know that during simulation, right, manufacturers can evaluate, for example, using 3D-ProSim, they can predict the thickness, right, of the glaze itself, right? The glaze distribution and whatnot, right? So these are factors that affect that. But the fact these days, with a defined process, which 3D-ProSim avails its customer, it makes things much more easier for the customer to achieve that. Thank you very much, Michael.
Okay, that was it with the questions. So we can also say thank you, and Samuel, you have the final.
Absolutely. Thank you so much, guys. We say a big thank you for joining us for our flagship webinar. And we look forward to see you more in our next incoming webinars. But also, you can please scan this QR code and you can make a personalized meetings for us. We would like to know you personally and would like to know your current situation in terms of your glazing and to find an ultimate solution for you using 3D-ProSim, right? And also, we will follow up with you guys after this call. We send you also a video of this where you can rewatch over again to get a more better overview of what 3D-ProSim could do. So we look forward to hear from you. Please do well to scan the QR code. And yeah, without further ado, thank you very much once more for joining us. And we look forward to see you for our next flagship webinar. Have a wonderful day and have a lovely week ahead. Thank you very much, guys. Bye.
Thank you. Bye-bye.